Okay, now the solutions to the complex equilibrium question. So first of all, we just need the fairly simple one of the equilibrium constant expression, and products have a reactance to the power of number of moles. That's fairly straightforward. Now the next part, we're asked to calculate the equilibrium constants of everything. We're told that the amount of iodine at equilibrium was 1.07 moles. It's nice we've got a 1 litre container, so when we work out the concentration it's going to be 1.07 divided by 1, so it's going to be the same. Now what are we told about the initial conditions? We're told we injected 3 moles of iodine and 2 moles of hydrogen into a 1 litre vessel. So we clearly know how much iodine and hydrogen were present initially. How much HI, hydrogen iodide, was present? Well, we were told what was put in there and no mention was made of HI. No HI was put into that initially. So the amount of HI initially is 0. If you're told what someone did, and if they didn't add something, then there's not going to be any of it there. It's a little thing you need to realise in quite a few of these questions. So we do our ice table, and initially 3, 2 and 0. Now what we're told is the amount of iodine present in equilibrium, and since there's 1 mole of iodine in the equation, that's going to be negative x. 1 mole of hydrogen in the equation, that's going to be negative x. 2 moles of HI is a product, so it's going to be positive, and it's going to be twice as much of it, plus 2x. So we work out what x equals. What's iodine gone down by? 1.93 moles. So that means hydrogen's going to go down by 1.93 moles. And hydrogen iodide is going to go up by twice that, 2 times 1.93, or 2.86 moles. Recognise then that the number of moles is going to be the same as the concentration because we've got a 1 litre vessel. Substitute those into the equilibrium constant expression and we've got ourselves an equilibrium constant. Notice how there are no units this time because the coefficients top and bottom cancel out. Now, a little bit of graph work, a little bit of important graph work. We're given the graph of the decrease in iodine concentration. On figure 1, on the first graph, we're asked to include on that graph how the hydrogen and hydrogen iodide concentrations changed over that period of time. So we go back to our table, and it's good that moles equals concentrations. So we can see that iodine, which is shown on the graph, goes down from 3 to 1.07. So initially 3, at equilibrium 1.07. Hydrogen, initially 2, at equilibrium 0.07, so quite close to 0. Hydrogen iodide starts off at 0, ends up at 3.86. So they're the values we're going to have to get on our graph. So we've got our iodine, starting off at 3, ending up at 1.07. So in drawing these graphs, first thing to make sure you get right is the initial position, so the initial numbers of moles. And what did we have? Hydrogen was initially 2. It's going to start off there. And hydrogen iodide was initially 0. It's going to start off there. Now, what were they at equilibrium? Well, hydrogen was down at 0.07. So what have we got? We've got each one of we got 5 boxes going up to 1. So each box is 0.2, 0.07 is going to be a little bit short of halfway. It's going to be roughly there. So, what is hydrogen iodide? Well, hydrogen iodide at equilibrium was 3.86. So that's going to be, well, that's 4 there. One box short is 3.8. 3.86 is going to be a little bit short of halfway again. So it's going to be there. So now we know where the graphs have got to start and where they've got to finish. The really important thing to do is to make sure they reach equilibrium at the same time. Now, where does the iodine graph reach equilibrium? Well, pretty much between 35 and 40 is when it becomes perfectly horizontal. So we're going to need to do exactly the same for these two. So from pretty much here across, just over 30 across, the concentrations are going to have to be perfectly horizontal because the system is at equilibrium. And the same for the hydrogen iodide line. It's going to be at equilibrium from about here on. How do we draw that line? We use a ruler. He says looking around for the board ruler, which of course isn't here when I need it. So I'm going to use this and I am going to rule a line. Always rule. And I can't even see where this one is, hopefully it will. Probably the best I'll do. No, I can probably do better than that, can't I? It is really important to get these graphs right. It's this is an old exam question, and getting the reaction reaching equilibrium at the right time is really important. Now, of course, the graph is, so now we link the two bits. So the graph is much steeper at the start, then flattens out. Oh, something like that. I've stuffed up the top probably. Make sure it's sort of, oh yeah. Put a bit of effort into getting those right, folks. It's important. You always do graphs in pencil. That's reached equilibrium too early. Something like that. So they are fiddly graphs to get right, even though you can sort of understand what it's got to look like. Actually getting that bit of equilibrium right is quite tricky. So rule the lines when it's at equilibrium, and then you might need a number of attempts to do that final little bit there. Now, and my Photoshop skills, I think, are even worse than the Workbook. That's what I came up with on Photoshop. So I recognise they're difficult graphs to draw, but you need to try and do it. And they were the parameters that we had when we look at the when it's an assessment item. Now, the next one, basically it was the iodine reaction if a catalyst was added. So what does a catalyst do? A catalyst speeds up the reaction, but doesn't affect the amount of product that is produced. So you're going to start off exactly as on the previous one. You're going to start off at, what did we start off with for iodine? 3. We're going to end up at 1.07? And so that's the starting point and the ending point. 1.07 starts off at 3. This time it needs to reach equilibrium earlier. So let's have it reaching equilibrium down here. Whoops, better get it done at the right spot. And that means it's going to be steeper earlier. So let's have it nice and steep early, then flattening out to reach equilibrium nice and early. And again, ruling that line. See, if you forget to bring a ruler to the exam, data book works perfectly. Except that's not exactly horizontal. I would redraw that probably. Yeah, I'm being OCD, but you got to get them right.